next topic is about the linear system of the differential equation. Sometimes some problem statement you have two dependent variable and one independent variable, just like this equation. For example, this differential equation you have two dependent variable, which is x and y. And in that case, you would have two differential equations. And here is the example of in the case that you have three independent variables, which are x, y, and z. And you have one independent variable. So the thing is that how can we find the solution of this type of differential equation? Let's take a look at this example first. Find the solution of this linear system. 2dx by dt minus 2dy by dt minus 3x is equal to c. And another differential equation is 2dx by dt plus 2dy by dt plus 3x plus 8y is equal to 2. We have two dependent variables, which are x and y, and we have one independent variable, which is t. And if you take a look at this differential equation, you find out that it's not a homogeneous differential equation. It is a non-homogeneous differential equation. So, in order to find the solution of this, we are going to use the previous technique, combining with the Kramer rules to find x and y as a function of t. The way to find solution is simple. You have to write down the equation in such a way that you have only one independent variable and one dependent variable. You can do by find the number to multiply and subtract the equation, but that would quite be difficult in the sense that the equation itself is in the form of differential equation. So the best way to find the solution should be by using the Kramer rule technique. Okay? So from this differential equation, we are going to write down in the terms of operator d. So the first equation, we would get 2dx minus 2dy minus 3x is equal to t. The term which has x, we put them together and then we take x out. So we would get 2d minus 3 times x and for our second differential equation, we are going to write it down in the terms of operator d. So we would get 2dx plus 2dy plus 3x plus 8y is equal to 2. Now we are going to rearrange this differential equation in such a way that we put x together and y together. So we would get 2d plus 3x plus 2d plus 8y equal to 3. So we have this equation and this equation that we are going to use. Please remember that when you take x, x should be behind d. Okay, you cannot put x in front of d because the meaning of this term would be changed. Because x times d is not equal to d times x. So anytime you take it out, you've got to put x at the back of the parentheses. The same thing as y. So now you have two equations which are and you have two equation and two unknowns. You can find x by using Kramer rule. Kramer rule saying that if you want to find x, the term which is on the right hand side of the equation, you just put it instead of the coefficient of x, so you will get t and t there. For y, you just keep it there. Remember, just take only the coefficient, don't take y and x. Don't put x here or y there. Don't put that. Divided by the coefficient of x and coefficient of y. Find determinants of 2 by 2 matrix. You would get 2d plus 8t plus 4d. Just combine them together. 2dt is equal to 2. d4 equal to 0. Right? Because the derivative of constant is equal to 0. This term, you got 4d squared minus 10d, plus 10d minus 24 plus 4d squared plus, which is equal to 80 squared plus 16d and minus 24. Take it out. Okay, I put 8 back in. Now, from this, you can see that you have no dependent variable y in this differential equation. From this, if I want to write down in the term of differential equation, I would get like this. Which is second order differential equation and non-homogeneous. So can you find the solution of this differential equation? You see that from the beginning, you have linear system. You got to find a way to write down the differential equation in such a way that in that equation have one dependent variable and one independent variable. And the way to do that is by using Kramer rule. Here, we're using Kramer rule. And from Kramer rule, what do we get? We get the equation, the differential equation, which is contained only one dependent variable and one independent variable. Now, from this, you can find the solution for sure, right? Your x is combined with xc and xc. To find xc, you've got to write down the characteristic equation. What is the characteristic equation? M squared plus 2m minus 3 is equal to 0. So from this you can find two values of m, which is m is equal to minus 3 and 1. So our xp is equal to c1 times exponential of minus 3t plus c2 times exponential of t. Then we can find xp. Our xp, we can use, it's up to you. You can use shortcut or you can use undetermined coefficient, or you can use possessive integration, but possessive integration might be difficult because you need to do by parts. So the simplest one for you, I think, is the shortcut. So I'm going to use shortcut technique to find the solution of this. So to find xp, you are going to write down your differential equation in the term of the operator d. So we get d squared plus 2d minus 3 which is equal to is a case 1, and you can use only case 1, or you can use case 1 and case 2. For case 2, the exponential term, now our s equal to 0. You put 0 in every term of your d, so you would get minus 3. For this term, you've got to write down 1 over pd in the terms of p0 plus pt1d plus p2d squared until d to the power k. But now the power k is equal to 1, so when you do dividing of this term, you do only the terms of d. I will get minus 1 over 3 and then we get minus 2 over 9d. And then we don't need to do more because we have only t here, so the rest of the term would go to 0 by its definition. So you would get these two terms, you can combine them together. So you would get minus 11 divided by 36. That is your xp. So your x is equal to xc plus xp. So you would get c1 times exponential of minus 3t plus c2 exponential of t minus 11 divided by 36 minus 1 over 3t. And that's for x. Now, we are going to do y. Y, again, doing the Grandma's rule. But for the dividing, since you divide it with the same term, so you take from here, your dividing term is equal to 8 times d squared plus 2d minus 3. And to find y, now, the coefficient of x, you just put it there. But the coefficient of y, you replace it with t and 2. Okay? So we will get plus 3 and t and 2 divided by 8 times d squared plus 16d minus 24. You don't need to do it again because it's just the same. I'm sorry. It's not 16, it's the 2 and minus 3 because we take 8 out. This is 2d and minus 3. Then determinant of this term we would get 2 times 2d minus 3 minus 2d plus 3 times t. 1 over 8d squared plus 2d minus 3, 4d minus 6 minus 2dt minus 3t. For d is equal to 0. 2 dt is equal to 2. And minus 8 minus 3t. Again, if you write down y, the equation of y is the second order differential equation, and it is a non-homogeneous differential equation. So y will combine with yc and yp. To find yc, you got to write out the characteristic equation, which is m squared plus 2m minus 3 equal to 0. So you can find two value of m, which is m is equal to minus 3 and 1, which is exactly as the same as xc. So from that, yc is equal to c1 exponential of minus 3t plus c2 times exponential of t. Now we find yp, 1 over 8 times d squared minus plus 2d minus 3. The function is pretty much the same, so you don't need to do dividing again. You can take from the x. You plug 0 into every term of d, so you got minus 3 there, minus and minus become plus, so you get 1 over 3. And then this term you will get, it is the dividing, minus 1 over 3 minus 2 over 9d and so on. Get 1 over 3 minus minus is equal to plus 1 over 8t. Minus minus is plus 3 and 9, you get 3 here and you got 4 there, so you got 12. And dt is equal to 1. get 5 over 12 plus 1 over 18. Now, your y is done. yc plus yp is the 1 times exponential of minus 3t plus the 2 exponential of t plus 5 over 12 plus 1 over 18. And that is your y. So you get both x as a function of t and y is a function of t. And that